Okay, so here we are at site 1 and we have our stream beside us. So we're going to do some water quality measures to start with, some physico-chem parameters. So we have our instrument down here, so I'll show you where we set that up normally. You can see I'm already gloved up because we need to, even though the streams here are generally reasonable, we're not sure of the condition, so we always take precaution from the outset. Not because Kerry's got any diseases, but just because. So what we have in our box here is a Quanta water quality multi-probe. So this is an instrument that is actually worth about $12,000, so you need to handle it with care. And it's like some of those instruments you might have used in a lab in school or in some of your other studies where there was an individual pH probe or individual oxygen meter, but all these are together in one instrument, and that's why they're expensive. So this is the main probe, and this is the screen that records the information. So what we need, it's in a little protective container, and we just need to get that off. And that's just distilled water in there just to keep it moist. So if we can zoom in on this, we have a series of probes from conductivity, temperature, pH, dissolved oxygen, turbidity and salinity are all on this one probe, and we can also measure depth. And so with this we can get the condition of the stream at this time. The reason why we take measures in situ is that it gives us that condition right now and then. If we take a water sample and take it back to the lab and measure it later, those conditions can change. So we need to measure it as it is in the stream when we're here. So this is the instrument. What we need to do is put on our little protective case, and this just protects the probes themselves. That just twists on there, and that then means that if anything hits that, it's not going to break your probes. So we've got a cable, and we'll demonstrate the technique and show you that in a minute. So. Okay, so we just wanted to show you a close-up of the instrument and then how to operate the actual instrument to start with. So this is, as you can see, the panel. There's a button down here at the bottom. That's the on-off button. Basically, you hold that down and it'll come on, and it kind of warms up for a bit, coming on, and you'll see something like this first appear, and it has a whole range of parameters down the side, from top to bottom. We've got temperature, SPC is specific conductance, we've got dissolved oxygen, pH, and so we see the numbers there, and they're jumping around a little bit, well, actually quite stable, but when you put it in a stream, they will jump around a bit. So what we do is wait until the numbers are stable before we actually get a reading. The other thing you might notice, there is a little flashing icon down there, or a word that says screen, and it's telling us there is a second screen of information. So we use the top button here to scroll between the two screens. And so I can click this, and you can see it's gone to a range of other parameters. So it tells us the battery life of the instrument, which is important if you're in the field for a long time. It tells us the salinity, the dissolved oxygen as a percentage, as opposed to milligrams per litre. ORP is the oxygen reduction potential, and the last one is turbidity. So whenever we record data, we need to obviously note this down in our books, but we also need to record the units they're in. So as you saw, and I can press the button again and scroll back to that first screen, and so you can record dissolved oxygen either as milligrams per litre or as percentage. And so you can convert between the two, but it's always good to record both, if just for ease of having the data there. So that's kind of a close-up of what the instrument looks like, and so now we'll actually get into the stream and get some measurements. So here we are down in our stream. We've made our way carefully down here. I'm on the stream, on a rock on a stream. Kerry's up there with the actual instrument. One thing we need to point out is, yes, we can immerse this. This is fully waterproof. All this cable's waterproof, all the way up until the instrument itself. So we never get this near the water, so that's why Kerry's up there with the actual reading panel and I'm down here in the water. Now, we've come to this particular point and you can see it's quite rocky in places. There's a lot of flow and shallow bits. They're called riffle areas. So where we want to do our water quality is in a pooly area. So it's a slower flow and it gives us a more representative value for the water. So there's not a lot of deep pools here because it's in the upper catchment. And so we found the best point where we thought we could get a representative sample, and this is our point. So what we're going to do is come down to the water. We've already got the instrument on, which we showed you earlier. And where we want to sample is as far out in the middle of the water, and because it's such a narrow stream, we're kind of in the mid-channel area. It's not very deep here, possibly 10 centimetres or so, maybe 15. And what I've done is I've immersed the probe down so that pretty much all that lower half of the device is underwater. So as long as all that's underwater, that's sufficient depth that you require. If you're in a deeper pool, you can do depth profiles because, as I said, all this is waterproof and you can take measurements generally every half metre to give you an understanding of what's happening at different depths. But here it's a very, very shallow stream, and so we're just, in essence, taking a surface measure is what it would be classed as. So we hold it just off the bottom as well. We don't rest it on the bottom because that can stir up some sediments and create, erroneous readings. And so we hold it there, someone's holding it there, and Kerry has the instrument up there, and she's looking at the readings until they're stable. As I mentioned earlier, they might jump around a bit because we've got parcels of water moving across the probes, and so when it's stable, then you would record. So you'd have someone recording in your field notebook the values. So Kerry is giving the thumbs up because I'm mic'd up and she isn't, but maybe Kerry, you can yell out some of the values you're seeing.
Yep. So temperature, 14.08 degrees. Just repeat.
14.08 degrees temp.
Temperature, yep, degrees Celsius.
Degrees Celsius.
Specific conductance, 0.046 millisiemens per centimetre.
Specific conductance, 0.046 millisiemens per centimetre.
Yep.
So we can convert that to microsiemens later to give us a better value.
Yep. Dissolved oxygen, 8.16 milligrams per litre.
Dissolved oxygen, 8.16 milligrams per litre. So that's quite well oxygenated.
Yep. pH, 7.53.
pH is 7.53. She's going to the next screen.
Yep. Salinity, 0.02 PSS.
Salinity 0.02 PSS, which is a practical salinity scale. So it's a relative salinity measure.
54 millivolts.
ORP, oxygen reduction potential, is 154 millivolts. So it's in the positive, so it tells us it's in an oxygenating environment.
And turbidity, 14.1 NTU.
And turbidity is 14.1 NTU, or nephelometric turbidity units. So it's not clear, but it's not super bad.
Sounds good. Right, so I'll be recording that in my notebook, and then we can move on to our next site and do some replicas.
Yeah, so we record all that, as Kerry just mentioned, if you didn't catch that. One thing about general protocols is that when someone's reading out the measures, the other person repeats the measures as they record it to make sure it is recorded correctly, to get rid of that human error. All right, so all done.